Bismillahirrahmanirrahim. Assalamu alaikum. I am Hira Miraj and today I am here to present my final year presentation. And these are my group member Muhammad Sikandar and Muhammad Mohsin Matloob. Our presentation is on research base and our title is the synthesis and characterization of pre-treated agricultural waste based polymeric composite. Okay. Firstly, I would like to thank Allah Almighty for granting us a chance to come in this institute and our project advisor, Mr. Muhammad Suleiman and Dr. Saima Yasin for helping us. And thanks to Chairman Dr. Tanvir Iqbal for providing us with all the facilities without which we couldn't have complete our research project. Okay. Here is the motivation of our research project is to increase the bonding adhesion between matrix and fiber. What is matrix and fiber? I'm going to tell you in a preceding presentation. To increase the bonding between them to induce properties of resulting composite in order to increase the properties of resulting product. Okay, these are two objectives of our project. First one is to perform chemical pretreatment on raw material and evaluate its physiochemical properties, and the second one is to fabricate composite sheets reinforced with treated or untreated rice husk both, and then analyze the properties of biocomposite sheets. Okay, firstly I'm going to tell you about composite, what is composite and what is biocomposites. Okay, composite is a material which is composed of two or more constituents and material with significantly different physical and chemical properties when combined produce a material with different properties from individual components, and there are two phases of it. First one is matrix phase and the other one is disperse phase. Matrix phase is a continuous phase which surrounds the other matrix, and the disperse phase is a phase which disperse in matrix phase. Okay, and these two like matrix and fiber like fiber provides strength and stiffness, and the matrix provide protects transfer and load between fiber, and when they both combine create a material with attributes superior to either component alone. Okay, there are two types of composites. First one is synthetic composites and the second one is biocomposites. We classified it on the basis of fiber. Okay, synthetic composites are man-made, it based on chemicals such as petrochemical, mostly derived from nylon, etc. And the fiber which we used in synthetic composites are carbon fiber, glass fiber, etc. And in biocomposites we use natural fibers. It may be industrial waste, plants, agriculture waste, lignocellulose, biomass, etc. So we are focusing now biocomposites. As I told you, biocomposite is a composite material formed by matrix and reinforced by natural fiber. Matrix is usually formed by polymer, and the reinforcement fiber may be industrial waste, animal waste, and lignocellulosic biomass. Okay, in our objective I told you about pre-treatment. Why pre-treatment? Pre-treatment is necessarily to enhance the bonding between matrix and fiber and to increase their binding with polymer. Okay, before pre-treatment there with cellulose, hemicellulose and lignin are also present. So we do pre-treatment to remove or reduce the quantity of hemicellulose and lignin. In this way cellulose contact comes to surface, and cellulose have binding properties, so it fiber binder interaction gets better after pre-treatment, or in this way decrease non-cellulosic impurities. Okay, there is a surface modification of material before pre-treatment and after pre-treatment. Before pre-treatment, as you can see, cellulose is enclosed within a hemicellulose and lignin, but after pre-treatment cellulose come to the surface and start interaction with polymer. Okay, why biocomposite, why not synthetic composites? Okay, biocomposite is not a only solution of growing environmental threat, but also a solution to alleviate the uncertainty petroleum supply, as synthetic polymer required a consumption of a remarkable consumption of energy and oil based resources. And the other one is and the other important point is eco-friendly. Biocomposites are eco-friendly, they don't emit any toxic gases, biodegradable, renewable and inexpensive raw material, and the most important thing, it emits low carbon dioxide emissions, which and carbon dioxide emission is not good for our it affect or global warming and greenhouse effect. So So it's good that it emits low carbon dioxide emission, because it increase or earth's temperature day by day. Okay, here is some application of biocomposites, like building and construction, automotive uses, packaging, electrical and electronics, and industrial products. In building and construction, we use it as an insulating walls, ceilings, and sheets. And in automotive uses, we used it for interior and exterior design of cars. In electrical and electronics, we used it in resistances. In industrial products, we used in pipes and fitting pipes and fitting pipes and fitting. And here we are and some equipment in industry, but we are focusing here on packaging. In packaging material, it also used in packaging for pharmaceutical food packaging, in packaging industry, and it is also used as a laminator. Okay. These are the following phases which are we following in our final year project. First one is selection of material, then pre-treatment, and then we have to make or fabricate biocomposite sheets, and then characterization and analysis. Okay. There are so many methodology to fabricate synthesis sheets, but here is which we adopted. Like firstly, we did literature survey, in which we learned what is composite, what is biocomposite, and what is sheets, where we can use it. And then we set up experiment, our first step is to select material, and then select chemical to pre-treat. From with we can pre-treat our raw material, and then it mixed with some other polymer, and fabricate a synthesis sheets, and then characterization. Okay. Okay, now I would like to invite Sikandar to continue this presentation.
Assalamu alaikum. I am Mohammed Sikandar, and I'm going to present my part of this presentation, which starts from selection of materials. So, as we know that a composite material consists of two materials. Number one, two constituents. Number one constituent is a polymer or a matrix phase, and other constituent is a natural fiber or dispersed phase. So firstly, we selected polymers. Now I'll tell you that how did we select polymers. There are a number of polymers in the industry, so we had to select the best one among them. So we chose five best and mostly usable polymers as which we are using in the industry. Number one is low density polyethylene, LDPE. Number two is high density polyethylene. Third number, polypropylene, then polystyrene and epoxy. But we chose LDPE. I'll tell you in the next slide why we chose LDPE. Next, kindly. So we focused on LDPE because we took all these five polymers and we compared their properties to each other, and we chose the best the component the polymer with the best properties, which was LDPE, because it was inexpensive, and most importantly its density was lesser than others. Next slide. So there are so many reasons that why we chose LDP. First of them is lightweight. Yes, LDP, the products being produced by LDPE are lightweight products. Why? Because the density of LDPE is lesser than other polymers. Good chemical resistance. LDPE and products of LDPE are chemically resistant to other chemical reactions. So we needed a product with good chemical resistance. After that, low cost and good processability. It is inexpensive, and good processability means that at the time of process when we are handling it to prepare our new product, it is easy to handle. High toughness. We need a good quality product, so our parent materials should be stiff and high toughness. Their toughness should be high. So after that, non-toxic. Our material is non-toxic. It means it cannot harm the person who is using it. After that, very low water absorption. Very low water absorption means it doesn't absorb much water, so the product cannot deteriorate with the time. Good barrier. It is good barrier in this sense that its structure is well compacted and uniform structure. Due to this reason, the chances of leakage are very low. Next slide. We have selected our polymer material. Now we have to select our dispersed phase in means natural fiber material. So we had three types of biomass or waste materials which we could use as our natural fiber. Number one are industrial waste. Industrial waste comprises of fruit covers and vegetables and more importantly palm oil in industries residual. These constituents as industrial waste. After that, we have animal waste. Animal waste includes poultry manure and residuals of residuals and waste of animals like buffalo, cow, and other animals. So these were the animal waste. After that, we have lignocellulosic biomass. Lignocellulosic term refers to lignocellulosic materials or plant biomass which we have. Uh, Lignocellulosic material is a material which consists of cellulose, hemicellulose, and lignin. Next slide, kindly. We will be focusing on lignocellulosic biomass. In lignocellulosic biomasses, we chose four materials with the best properties. Uh, we have to select a material with the highest number of highest quantity of cellulose and lowest price. So we chose rice husk. Next slide. Why rice husk? Uh, there are many reasons to choose rice husk. Number one is high flexural strength. It means that the products being made by rice husk, when we put force on them to bend them, they don't bend easily. This property we need in our final product, so we chose rice husk. Number second, high tensile strength. Its tensile strength is also high impact energy. It means when we apply force on our material, it can withstand at high impacts also. If eco-friendly, burning of rice husk and other procedure up to getting rice husk raw material, it is totally eco-friendly. It doesn't produce much of the NOx, SOx, and other greenhouse gases, so it is environment friendly. And after that, biodegradable. Our material is biodegradable, which makes it unique because we are going to fabricate a biocomposite material. So it is biodegradable, which is very helpful for our final product. Easily available.